All right, so in this video, we're going to find oblique asymptotes only. So I'm going to be going through these two examples where we want to find all asymptotes, but these examples will also have an oblique asymptote. So let's get to it. Okay, so for the first one, so I've got x squared plus 2x over 2x plus 1. So for the vertical asymptote, so let's just knock that out. So to do that, I just set the denominator equal to 0, and then I can just solve for x to get that x is going to just equal -1/2. Okay, so let's clear some space. And so in my lesson video, I had discussed how to find asymptotes. And specifically, I talked about with oblique asymptotes, what happens is this is 1 degree higher than the denominator. So the polynomial on top is 1 degree higher than the polynomial in the denominator. Okay, so to find the oblique asymptote then, like you know right away, it's going to have an oblique asymptote. You don't have to think about any farther than that. So to do that, we need to use polynomial division. So I'm going to divide this by this. So the thing with this problem is that we actually can't use synthetic division here. So I have been using synthetic division in this series. So the thing about synthetic division, so just as a reminder, synthetic division requires that you're dividing something like x minus a or x plus a. So basically you can't have any number in front of the x. So because we have 2x plus 1 here, we actually cannot use synthetic division. So we're just going to have to use polynomial division. And so this can be a good review. So let's go ahead and set it up. This is kind of a trickier polynomial division, I think. Okay, so for polynomial division, it's all about first terms. And all you have to think about is what do you multiply 2x by to get to x squared? So I multiply 2x by 1/2 x. 1/2 x times 2x will give me x squared. So I multiply this out. This comes out to, x squared. And then I take 1/2 x times 1. So that's going to be plus 1/2 x. And now I subtract this off. Okay, so now I've got 2x minus 1/2 x. The x squareds drop out. So 2x minus 1/2 x. That is going to give me 3 over 2x. I'm just going to leave it all in fractional form. Okay, so now we repeat the process. What do I multiply 2x by to get to 3 over 2x? You might have to think about this for a second. But this will be 3 over 4. So now if I multiply 3 over 4 by this, so 2x times 3 over 4. So just to write that out, 2x times 3 over 4. Well, that gives you 6x over 4, which is 3x over 2. So 3 over 2x. So that gives me 3 over 2x and then plus 3 over 4. And once again, I subtract this result off. So the x's drop out and I'm just left with -3 over 4. This is the remainder. So the remainder you always just discard. So the oblique asymptote then will be the equation 1/2 x plus 3 over 4. Okay, so for number 2 here, so I've got x squared plus 2 over x plus 1. So in this case, so first just to find the vertical asymptote, so I set the denominator equal to 0 to get that x equals -1 as my vertical asymptote. So okay, we're all good there. I can clear some space. Okay, so now to find the oblique asymptote. So in this case now, I've got this divided by x plus 1. I can use synthetic division here because I'm dividing by something in the right format. So for the synthetic divisions, remember you always just take the opposite of whatever this number is here. So we'll put -1 on the outside. And then this becomes 1, 0, and 2. So there is no x term, so it gets a 0 placeholder. So now I can do the synthetic division. So I bring down the 1, multiplied by 1 times -1 is -1. Add those together, that's -1. -1 times -1 is 1. This becomes a 3. So the way that I interpret this starts out as the x column. This is the constant column. This is the remainder column. So I can interpret this then as my oblique asymptote is x minus 1. So there's my oblique asymptote. Okay, and so there are 2 examples just to show you how to run through that. So that's it for this video. I will catch you guys in the next one.